Welcome back. In the last video, we programmed the move forward and move right functions, and we set up axis mappings so that we can press the WASD keys to call these move forward and move right functions. We bound the move forward and move right functions in setup player input component here in our character class. So now we're ready to implement some turning. Now the first thing we're going to do is we're going to implement some functions that rotate the controller at a certain rate by using the arrow keys on the keyboard or the right thumbstick on a controller. So a lot of shooter games use the right thumbstick on the controller to allow you to look around, and the right thumbstick is often pressure sensitive. So we'll be able to see that. So first, in shooter character, let's add a couple of private variables here. And these are going to be the base turn rate and base lookup rate. And these are the rates at which you can turn as if you were turning your head side to side to say no, or look up as if you were nodding your head to say yes. These are going to be float variables. I'm going to call the first one float base turn rate. Now, it's going to be a U property. And I want this to be visible anywhere because I want it to be visible from blueprints, but I don't want to be able to change it from blueprints. I only want to be able to change it from here in C++ code. We're going to make this blueprint read only so that we can get it from the blueprint event graph, but we can't set the value from blueprints either. And I'm going to put this in the category camera. Now, let's give this a comment. And the comment is going to say base turn rate in degrees per second. Other scaling may affect final turn rate. So we're going to set this up so that whatever the value we give base turn rate, we're going to turn that many degrees per second while the arrow keys are being pressed or while the right thumbstick is pressed all the way in a particular direction. So just like base turn rate, we also want a base lookup rate. So this will be a float as well. Base lookup rate. I want this to have the same U property specifiers as base turn rate. And for the comment, let's say base look up / down rate in degrees per second. And then again, other scaling may affect final turn rate. So these are the base lookup and turn rates. If the values are scaled later on, then these will be affected. For example, the value fed in through the axis mappings, which correspond to, say, the pressure sensitivity of the thumbstick, will affect this, and we'll see that. Now, we're going to make a couple of functions for handling the turning at this rate. So let's go to our protected section, and let's make a couple of void functions that take floats. The first will be turn at rate, so void turn at rate. Takes a float, and we'll call this rate. Let's go ahead and make a comment, and I'll go ahead and make this a multi-line comment. I'm going to say called via input to turn at a given rate. And we can describe the parameter rate by saying param rate. This is a normalized rate, i.e. 1.0 means 100% of desired turn rate. So this explains a little bit about rate. Whenever the input, say from our controller or the keyboard, results in rate being a value of 1, that's the maximum for the turn rate. If the right thumbstick is only pressed a little bit and we get some value that's less than 1, then rate will be lower, and that's why the base turn rate could be scaled by that, because we're going to multiply them together. Next, let's make another function called look up at rate. So void look up at rate, which takes a float rate. And let's give this one a comment as well. And this one will say called via input to look up/down at a given rate. And let's describe the param rate here as well. This is a normalized rate, i.e. 1.0 means 100% of desired rate. So these comments help explain our intentions here. Let's go ahead and create definitions for these. There we go. Now back in shooterCharacter.cpp, we have our turn at rate and look up at rate functions. Now the turn at rate is going to affect the controller's yaw. Again, it's like you're shaking your head no or looking both ways before you cross a street. The way you're turning your head that way, that is your head's yaw. And so we want to change the yaw of the controller. We're going to use the function add controller yaw input. Now add controller yaw input simply takes a float value. And what we're going to do is we're going to pass in rate. That'll be a value between 0 and 1 based on the key press or the thumbstick. We're going to multiply this by our base turn rate. And also we're going to multiply this by delta time. Now we can get the delta time each frame by calling getWorld, and from the world pointer that's returned, get delta seconds. That gives us delta time. So this normalized value between 0 and 1 will scale this. If we're not pressing any key or the thumbstick, rate will be 0. So we're not going to be adding any yaw input. And if we are pressing the key, it'll be a value of 1. And if we're pressing the thumbstick all the way, it'll be a value of 1. Or if we're only partially pressing the thumbstick, it'll be some value between 0 and 1. We're also multiplying by the base turn rate. Now because this is called every frame, we're going to multiply by delta time. And this results in the exact value necessary to rotate our controller by base turn rate degrees per second. You see, the units of base turn rate are in degrees per second, and the units of delta time are in seconds per frame. That's how many seconds have passed each frame. And if you multiply degrees per second times seconds per frame, if you recall from math, multiplying these fractions, you have the seconds in the bottom, the denominator, for this fraction, and the seconds in the top, or the numerator, for this fraction. Seconds cancel, leaving you degrees per frame. And if this is called every frame, then we're getting the correct number of degrees per frame to add to the yaw of the controller. Let's comment this and say, calculate delta for this frame from the rate information. Now, how much is base turn rate going to be? Well, generally you'll experiment with values until you find what you like. But for now, I'm going to use a value of, say, 45 for base turn rate. And we can initialize this in the constructor. I'm going to stick it up here where we can initialize values with an initializer list. So we're going to say base turn rate, and we'll pass in the float value, let's say 45.f. While we're at it, we can initialize base look up rate. And I'm going to also give this one 45.f. Okay, now we can implement the other function, look up at rate. This one will be similar, only since we're looking up and down, this is the controller's pitch that we're affecting. So let's call add controller pitch input. So it's going to be multiplied by rate. We're going to scale this by base look up rate. And of course, we're scaling this by delta time. So get world, get delta seconds. And I'm just going to comment here, just like I did in turn at rate, degrees per second times seconds per frame. Okay, so these are the functions that we need to bind to our axis mappings, but we haven't set those up yet. So let's go back into the editor and we'll go to Project Settings and Input, and we're going to add new axis mappings. Let's add 2 of them. The first one we'll call Turn Rate, and the second one we'll call Lookup Rate. Look up rate. Now for turn rate, we're going to use the right and left keys. So go ahead and click this key button and click the right arrow key on your keyboard. And that'll give us the right key. Let's add another one. Click the key button, press the left key on the keyboard, and we're going to scale this one by -1. We also want the gamepad right thumbstick. We're going to use the x-axis. So let's type gamepad right thumbstick, and we're going to choose x-axis. For lookup rate, let's click the key and use the up arrow, and then we'll add another one, click the icon to select a key and use the down arrow and scale this by -1. And we're finally going to add the gamepad right thumbstick, and we're going to use the y-axis for that. Okay, we can close that. And the last step here is to bind these in Setup Player Input Component. So let's go down here, and we're going to use Bind Axis just like we did for Move Forward and Move Right. So we can actually copy these and paste them just underneath, but instead we're using Turn Rate. Remember, this was the name we gave the axis mapping in Project Settings. And for turn rate, we're going to use the function turn at rate. We also have look up rate. That's the name we gave it in the project settings. And we're going to map this to look up at rate. Okay, now we can compile this. Okay, so compilation failed. It says 0 succeeded, 1 failed. So I'm going to go into the editor, and I'm going to try to hot reload from the editor. This can give me extra information if I'm not sure why my compilation failed. Okay, so it says compile failed, show log. I'm going to click that, and it gives me this log, and it says log compile error, blueprint read only should not be used on private members. And it's even telling me the line in shooter character where my error occurs. And there's 2 of them because I have 2 floats that we made private that we gave blueprint read only to. If you'll recall, those are base turn rate and base lookup rate. So these are private and they're blueprint read only. So how do we reconcile this? Well, that's why we have the meta allow private access equals true uProperty specifier. If we add these to the uProperty macros for base turn rate and base lookup rate, then we can still have them be private variables in C++, but still be accessible in the blueprint. Let's go ahead and compile this again. Okay, let's hop back in the editor, press play, and click in the viewport. And I'm going to use the arrow keys first. Pressing the up key makes me look down. Pressing the down key makes me look up. Left makes me turn left. Right makes me turn right. Now I'm going to grab my console controller and use the right thumbstick. And that is also allowing me to move around. So I can move around in the world, and I can also look, and that is allowing me to look around. And look at the pressure sensitivity of the thumbstick. If I barely touch the thumbstick, I turn very slowly because that rate float value is very low. If I press it all the way, then that rate value is all the way up at 1. And then, of course, pressing with the arrow keys on the keyboard give the rate a value of 1 as well. And of course, left and down are scaled by -1 because we set those up to be scaled by -1 in the project settings. So that concludes this video. In the next video, we'll set it up so that we can alter the rotation of the controller using the mouse, which is very important for shooter games. And we'll also implement some jumping functionality as well. We'll see you in the next video.